right, so let's take a look at section 3.4. Okay, 3.4 is on synthetic division. Okay, we'll get to that towards the middle. And rational zeros. All right, so functions can have rational and irrational zeros. Okay, I think it was Cameron that asked me about one that had square root of 3 as a zero. Well, that's irrational. Okay, square root of 3 cannot be written as a fraction. Right. If you got a root like 3.4, like I think it was Kyle had something like that, 3.4, but he wrote it as a fraction. Is it 17/5? I think that's what it was.
Yeah.
That was rational. Okay, that was a root you could write as a fraction. So some roots you can write as fractions, some you can't. All right, I'm going to give you a theorem that will enable you to find all the rational roots. Okay? Or at least make a list of possibilities. Okay. All right, so this theorem allows us to make a list of what could be the rational root. Right? And then to actually confirm it, we can use our calculator, or I'll show you how we can use synthetic division. All right, so suppose we just had a polynomial. That's just the general form of a polynomial. Okay, like 4x cubed minus 8x squared plus 6x plus 7. Okay, just some polynomial. Okay. All the coefficients, all the numbers in front of x, they all have to be rational. Okay. Meaning we're not dealing with imaginary numbers. Okay. And we're not dealing with something like this. We can't have an irrational number in front of the variable. We can have a fraction, but not a square root, not an imaginary. Okay, fractions are as bad as the numbers can get. Okay, and there's just two restrictions on what the first one and the last one can be. Two things I circled in red. They can't be 0. All right, but they can be anything else you want besides 0. Okay, and I'll never give you a problem where they are 0 anyway. Otherwise, this theorem wouldn't work. All right. So when we look at our polynomial, if it has a rational root, okay, if it has a root in it, you can write as a fraction, which it's no guarantee that it does. Okay, but if it does, we could write it like this. It could be written as a fraction p over q. Okay, now what's p and what's q? Okay, p is all the factors of the constant. All right, so let's say the constant was 6. A factor of 6 is all the numbers that divide into 6 without a remainder. 1, 2, 3, 6, and all the negatives. -1, -2, -3, -6. Okay. And the denominator, q, okay, that's all the factors of the leading coefficient. Right, so let's say the leading coefficient was 4. Well, then our possibilities for q would be 1, 2, and 4. Right, so in the example I just made up, where p was 6 and q was 4, there's a lot of combinations. We basically have to match up everything I said with p with every possibility for q. So there's a lot of different possibilities. Okay, but all the possibilities we come up with, I'm not saying every single answer we get is going to be a root. Okay? We're just generating a list of possibilities. How do we actually figure out which ones in the list work? Well, we could use our calculator. All right, so we'll go through an example and you'll see how it works. All right, so I want to take this polynomial and I want to list all the rational zeros. You know what? I'm going to put a word in here, all possible. Okay, we're going to make just a list of possibilities. There's two numbers you need to focus on. -6 and +10. Okay. So P is all the factors of the constant. All right, so what are all the numbers that divide into -6 or +6 has the same factors? 2, 3, 6, and 1. And all the negatives. So 1, 2, 3, 6. Okay, so if there's a rational root in this problem, I guarantee you the numerator has to be one of these numbers. Positive or negative, 1, 2, 3, or 6. If there's a rational root, then the denominator has to be a factor of 10. Okay, that's what the theorem says. It has to be a factor of 10. So what are the numbers that divide into 10?
1, 5, and 2, and 5.
1, 10, 2, 5, yep. And all the negatives. 1, 2, 5, 10. Okay, so if there's a rational root, the denominator has to be one of these numbers for Q and one of those numbers for P. Okay, now we need to match up all the combinations. Okay, so I'm going to try to show you a systematic way to do it. Pick one of the P values and then put it over every Q value. All right? Every combination of P over Q could be a root. Right? They're not all going to be roots. That's where we'd use the calculator. All right? So start with 1 over 1. Okay? And then 1 over 2. Okay, we could have 1 over 5, positive or negative, and 1 over 10. Okay, any question on what I just did there? Just took one value for P and tried every different value I could have for Q. Okay, we might see some repeats as we go through. Okay, now I'm going to take 2, and I'm going to list all the possibilities I could have with 2. 2 over 1. How about 2 over 2? Do I already have that one? Yeah, we already listed that one. 2 over 5, did we list that? Nope. How about 2 over 10?
Yeah.
Yes, we already listed that. Okay, so we don't need to list 2/10 because it's the same as 1/5. All right, now we'll go to 3. 3 over 1. 3 over 2. Nope, I don't think we have that. 3 over 5, we don't have that. And 3 over 10, we don't have that. Okay, and the last one is 6. Okay, 6 over 1. Nope. How about 6 over 2? 3. Already got that. 6 over 5? Nope. And how about 6 over 10? That reduces to 3/5. We already have that one. So, if there's a rational root in this problem, okay, if there's a root you can write as a fraction, I guarantee you it's one of these. It has to be. Okay. So this gives us a list of possibilities. How do we narrow it down further? Graph it. Okay. See if it looks like there's a root near 2 or 1/10 or 1/5. So it kind of tells you where to look in the window. So you're not going to find any rational roots except between -6 and 6. Looks like 6 is the biggest and -6 would be the smallest. So you don't have to look beyond that if all you want to find is rational roots. Okay, any question on how we generated this list? Yep.
For the P and the Q, you pull that out of the top one?
Yep. P is all the factors of the last number. Q is all the factors of the first number. Yep. All right, I want to use that same problem. I'm going to graph it now. I want to show that it only crosses the x-axis one time. And I want to prove that that root is irrational. All right, so let's just graph it, see what it looks like. So we got 10x to the fifth minus 3x squared. Plus x minus 6. I'll just start with a standard window. Okay, I'm telling you it's only going to cross one time. Okay, so we already know that. There's where it crosses. Okay, let's find where it crosses. Okay, we're using the graphing calculator to help us out. Okay, I don't know any other way you could find where it crosses without using the calculator. Okay, because this is not a quadratic, so you couldn't solve it using the formula we know. Probably doesn't factor nicely. Factor by grouping probably is not going to work. So really, you got to use the calculator. So pick a point left, right, and the guess. Okay, so the root is at 0.951. And it's approximate. Right, so it said, prove that this has to be irrational. How can I use what I just did to prove that? Well, I'm going to tell you you can't make this a fraction, which is a hint. How come 0.951 has to be irrational? Think about what we just did. Yep. It's not in that list. Right? You got numbers like 1, 0.5, that's 0.2, it's 0.1, that's 0.4, 1.5, 0.3, I could keep going through them. 0.951 is not any of these fractions. Okay? These are all the rational roots. If there's one in this problem, it has to be one of these numbers. We got a number that's not in the list of rationals, so it has to be irrational. Okay? It's not in the list of rationals. All right, so since 0.951 is not in the list, possible rational roots, and this list is complete. There's nothing missing from it. This is the entire list of what could be rational. So if it's not in that list, it's got to be something else not in that list. The only thing other than rational is irrational. Okay. Any questions on that? All right. Okay. Everybody have that? That's the explanation. All right, so Tyler's favorite. Instead of long division, we can use synthetic division. Okay, synthetic division is a little easier, a little faster. If you have a certain type of problem, okay, it can only be used if you're dividing by something that looks like that. Okay, so you can't have x squared in the bottom. Generally, you don't want to have something like this. Can't have a 3 in front of the x. Just an x, a minus, and a number. Okay, so what I'll do is I'll give you the steps first, just like we did yesterday, and then we'll do an example, rather than me writing a step and then doing one step in an example and then back to the steps. Okay, I'll give you all the steps first. All right, first thing, write down the number that comes after the minus sign. We usually put a little bracket. And then all you're going to do is write down your coefficients of your numerator. Okay? You're not going to write down any letters in this whole process. It's all numbers. Okay, just like yesterday, if you're missing a coefficient, what do you have to fill in for that to hold the place? Yeah. If you don't fill in zeros for missing powers, it will come out wrong.
When you fill in for the zero, does it matter if it's minus or plus? Like zero?
No, positive 0, negative 0, same thing. Yeah, we'll just go with 0. Yeah. All right. So after you write down the number after the minus sign, and then you fill in your coefficients, you're going to take the first term you wrote and bring it down. All right, so just bring down the first coefficient. Okay, next, you're going to take that number you just brought down, and you're going to multiply it by whatever's on the outside, C. That's your divisor. Right, so take the number you just brought down, multiply it by the divisor, and then you're going to write the result in the second column. Okay, and then once you write that result in the second column, you're going to have a number. You're going to have two numbers in the column. You're going to add them up. Okay, you're going to add them up, and you're going to write the answer. And then you basically keep repeating this process. Okay, you take the answer you just got when you added the two numbers up, multiply it by C, write it in the third column, add the numbers up. Multiply again, write the answer, add the numbers up. So you just keep multiplying, writing the answer, adding up. Multiply, write the answer, add them up. Okay, and you keep repeating until you're done. Okay, when you're done, okay, all the numbers that you added up, all the answers that you got as you went through the problem, those are going to be the coefficients of the quotient. And the answer that's farthest on the right is going to be the remainder. Okay, it seems confusing when you kind of write out the steps, but it's actually very, very simple. All right, so I'm going to use those 4 steps to do synthetic division here. So they're asking me to show that 3/2 is a 0, okay, or a root. Okay. In the homework, we did a problem kind of like this. Right? If 3/2 is a root, then what would be a factor? Right. What we're really going to show is we're going to show that this is a factor. Well, that's the same thing as showing this is a root. Okay, remember that list of like 5 things I wrote? They were all equivalent. If C is a root, C is a 0, C is an x-intercept, x minus C is a factor. So this is what we're really going to show. And how do you know when you do division if something is a factor of something? You focus on the remainder. What are you hoping that happens? It comes out to 0. So all we're really going to do is we're going to divide this into that and hope we get a remainder of 0. If we do, then this is a factor, which means this is a root. Okay? So to divide it, we're not going to use long division. You could. But we're just going to put the number after the minus sign on the outside. And I'm going to put down my coefficients on the inside. Cube, squared, first power, constant. Not missing anything. So 2, -5, 1, 3. Okay, draw a line. Bring down the first coefficient. 2. Okay, next step. Multiply the number I just brought down by 3/2. Put the answer in the second column. Okay. What's 3 divided by 2 times 2? 3. Add the number you just wrote and the one that's above it, the second coefficient. What's -5 plus 3? -2. Repeat. Okay. What's 3 divided by 2 times negative 2? Negative 3. Add the number you just wrote. 1 plus negative 3? Negative 2. Multiply again. We're getting a lot of the same number here, just kind of a coincidence. But negative 2 times 3 over 2 is negative 3. And what's 3 plus negative 3? That's my remainder. So, because I just got a remainder of 0, I just showed that this divides evenly into the numerator, which means this number is a root. It's a 0. All right, so now my quotient is, this is your remainder, and this is your constant. That's your linear term. That's your squared term. So it's 2x squared minus, that's the x term, minus 2. Right. And the last thing they said to do is write this in factored form. 2x cubed minus 5x squared plus x plus 3. Well, when we did the division out, what did we prove was a factor? X minus 3 halves. Just squeeze it in here, times. Now, what's the other factor?
Negative 3.
Yeah, my quotient. All right? Just like if I said to you, 6 is a factor. Well, divide by 6. Look at the answer you get when you do the division. You get 2. That's the other factor of the numerator. Right? We did the division out. That's the other factor of the numerator. 2x squared minus 2x minus 2. So that is how you would factor this. Right? And that's usually how we have to do it. Okay? We have to find one root that's rational. If you can't, you're stuck. Okay? So I got to give you a root that's rational. You'll get one factor, and then your quotient. That's the answer. Yeah?
What if we have a remainder?
The remainder? No remainder in this problem. If there was a remainder, you wouldn't be able to factor it. Okay? If I ask you to factor it, got to get a remainder of 0. Yep.
So is that just the answer in factored form?
Yeah, this is the answer in factored form. Yep. I guess in this last part, there's a 2, and a 2. You could factor a 2 out of each one, but that's fine. Right? So that's how you could factor that. Without synthetic division or long division, that would be very hard to just figure out by trial and error. You wouldn't figure that out. Okay, gotta use some method to help you. All right, so very similar to the last one. We're just gonna use synthetic division. Okay, that's how I abbreviate it, SD. To find the quotient and the remainder. Now is that what it's supposed to look like when I do synthetic division? Not quite. It's supposed to be x minus. But you can do it with x plus. How can you rewrite it as x minus? X minus negative 3. Think of x plus 3 this way. Okay. Now when you do synthetic division, take the number after the minus sign. What's the number after the minus sign here? Yep, that's the biggest mistake people make. When it's like this, they put 3 on the outside. Okay, the only way you'd put 3 on the outside is if that was the original problem. 3 is what's after the minus sign. Okay, and what will my coefficients be here?
3, 7, 0, 1, negative.
Good, so you caught the 0. You're missing the squared term. 3, 7, 0, 1, negative 11. Okay, and let me show you how fast synthetic division can be if you're reasonably good at arithmetic, which hopefully I am. So bring down your 3. Negative 3 times 3 is negative 9. That gives me negative 2. That gives me 6. Add, I get 6. 6 times negative 3 is negative 18. Negative 18 plus 1 is negative 17. Negative 17 times negative 3 is positive 51. Take away 11 is 40. Done. That's the whole problem. Okay, let's double check, make sure we got it right. 3, negative 2, 6, negative 17. Yep. And 40 as a remainder. Right, now they asked us to identify what? Quotient and remainder. Okay, let's start with the remainder. Brendan, what's the remainder here?
40.
Yep. And somebody else give me my quotient. Yep, Upi.
3x cubed minus s squared plus 6 minus 7.
Yep, 3x cubed minus 2x squared, what?
Positive 6 minus 7. Minus 6x. Positive 6x, right?
Yep, positive 6x minus 17. Okay, so there's your constant, x term, x squared, x cubed. So now I could ask you, is x plus 3 a factor? No, it didn't go in evenly. There was a remainder.
How do you get 51? 17 times 3?
Negative 3 times negative 17.
All right.
Yep. So you always kind of multiply on a diagonal, this times this, and put the answer there. And then add. And then that times that, put the answer there, and then add. And then add. Well, the other thing that's nice about synthetic division is it doesn't take up any more vertical space. Once you lay out the problem, it's never going to go below this point. With long division, you just kind of keep going off into the right. It goes way, you need a lot of space. Okay, so this takes up less space too. Right, how could I do that? It says show 3 is not a root, or show 3 is not a 0. There's a few ways you could do it. I don't want to do it graphically. Okay, you could draw a picture and say it doesn't cross the x-axis at 3, but let's not do it that way.
Change 3 to a factor, so x plus 3.
All right. So now, instead of showing 3 is not a root, you could show this is not a factor. It's the same thing. And how do you show this is not a factor? Divide it in and hope that what happens?
It's not 0.
Hope you don't get a 0 remainder. Yep, because we're showing it's not a factor. All right. So now I look at the number after the minus sign, which is 3. Divide it in and look at the remainder. So you got 2, 5, negative 2, negative 3. No zeros this time. Okay, bring down my 2. 3 times 2 is 6. 5 and 6 is 11. 3 times 11 is 33. Minus 2. 3 times 31 is 93. Minus 3, 90. I got a remainder of 90. Okay. This shows, what was it? X minus 3 is not a factor. So 3 is not a root. Okay, now the other way you could have done it is use the remainder theorem. Okay, remember yesterday I said if all you want to know is the remainder in a problem, you don't have to do division. Just take the number that comes after the minus sign, fill it in for x, and it will tell you the remainder. Okay, let's try it that way and see if we get the same remainder. Take 3, plug it in for x. So 3 cubed plus 5 times 3 squared minus 2 times 3 minus 3. I'm not saying this way is going to be faster. I think the synthetic was pretty fast, but we didn't even need all this stuff. We didn't need the quotient. All right, let's check it. All right, 3 to the third power is 27. 3 squared is 9 times 5 is 45. Let's see, 2 times 3, it's negative 6. Okay, 2 times 27, what does that give me? 54? All right, let's add it up. 54 plus 45 minus 6 minus 3. You got 90. Okay, so there's another way you can get the same answer. Fill in the number after the minus sign for x. There's your remainder. Okay, or use synthetic, whichever way makes you happy. Okay, so I'll just put here, this was using remainder theorem. Any questions on that? All right. All right, so in general, the strategies for finding your rational zeros. Okay. Use your rational root theorem. That's what that stands for. Okay. Generate a list of possibilities. Use the graphing calculator to narrow down that list. Sometimes the list is pretty big. Think of the first problem we did. It might have been 12 or 15 possibilities. So the calculator can help us narrow it down. And then once we find one that actually works, use synthetic division and divide through by that root. All right. So this time I want to find all rational zeros of this one. Okay, this is more reasonable. It's a lower degree polynomial. Okay, it's only cubic. So if we can find one rational root and divide through by it, every time you divide through by a root, you make this exponent one smaller. If we can make this cubic into a quadratic, we're good. Okay, quadratics we can solve all kinds of ways. We've got the formula, we've got factoring. Okay, but we've got to find a root first and then divide through by it. Let's make a list of possibilities. Okay, what are my possibilities for p? Plus or minus 1. And anything else? Plus or minus 2. Okay, there's not that many possibilities here. And there's even less for q. What are the numbers that divide into 1? Just 1 and negative 1. Okay. Now make a list of all the different p over q options you could have. Okay, what could you have? 1 over 1. What else? 2 over 1. Positive or negative. So there's 4 possible rational roots. Okay, next I'm going to graph. I'm going to look and see if it looks like it crosses the x-axis near one of these. And if it does, I'll use synthetic division and divide through. All right, so it's x cubed minus 3x minus 2. Okay, you start with your standard window. Okay, looks like we have a couple possibilities. We've got negative 2. What does it look like it's happening at negative 2? When the graph comes up, it touches and it goes away from it quickly. Does anyone remember from yesterday? Yeah? Yeah, it could be a repeated root. All right? And then we also, looks like we have a root at 2. Okay, I'm going to use the calculator and type in 2, and I can see that it is a root. So what I'm going to do is divide through by 2 using synthetic division. I already know the remainder. It's going to come out to 0. But what's going to happen when I divide through, that cubic is going to become a quadratic. Then we'll be able to factor it and get the remaining roots. All right? Now, if you didn't want to divide through by 2, you could try negative 1. You could try any number that looks like it's a root. Okay? But use your table to check that it really is a root so you don't waste time. All right, so I'm going to divide through by 2, because I think that's a root. I know it's a root. I checked it.
Above, what does GC mean?
A graphing calculator. Yeah, rational root theorem, graphing calculator, synthetic division. All right, so we got coefficients of 1, 0, negative 3, negative 2. right, so bring down the 1. 2 times 1 is 2. 0 plus 2, 4, minus 3, 2, 0. Perfect. We knew we should get a remainder of 0, and we did. All right, so we just proved that's a factor. Okay, so I'm going to start making a list of my roots. 2. Okay. And what's the other factor? We have x minus 2. And look at my quotient.
X squared.
X squared. Yep.
Plus 2x.
Yep. Plus 1. Okay. We already got the root here. Now we got to find the 2 roots here. Let's see if we can factor that. So we have an x and an x. How does that factor? Okay, we could try plus 1 and what about here? Yep. Now let's try it. X squared plus x, that's 2x, plus 1. Okay, what value would you plug into this factor to make it 0? What value would you plug into this factor to make it 0? We already kind of expected that's what was going to happen. We looked at the picture. It went very close to -1 and turned away quickly. So we were thinking it would be a repeated root, and it was. So my roots in this problem are 2, -1, and -1. So there are 3 answers. It's just one of them is repeated. You don't have to write the answer twice. You could just put here repeated. There's a better name for that, but I'll teach it to you later. All right. Hey, any questions on that? Yeah.
So how did you factor out the 3 numbers in parentheses to get the roots?
To get these 2?
Yeah.
Yep, I just factored that like you would in Algebra 1.
Okay.
It's a quadratic.
To decide on the 2 is the divisor to just graph it.
Yeah, to decide on the 2, I made my list of possibilities. I saw that 2 looked like, or 2 is a possibility. I looked at the graph and I said, well, it looks like it goes through 2. Let's try it. So I used the list and the picture to help me narrow down what to try. Yep.
So do you even have to use the graph? Because like for the table with the P and Q, you can see that plus minus 1 is repeated.
Yeah, you really,
So do you even have to boost the graph?
yeah, you could just plug all 4 of these numbers in and see which one work. Try -2, nope, that's not 0. Try +1, nope, that's not 0. Try -1, nope, that one's 0. Okay, I do want to see the synthetic division, but you could jump right to the table. Yeah. Because I'm gonna look for that quotient right there to see that you know how to factor that. Yeah. Right, and if you decided to use synthetic division with the -1 first, okay, and you did that on the outside, you'd get the same answers we just got. You'd still get the same answers to the problem. So there's different ways you can do it. All right. So we'll try these 2, and then I think that'll be good. Okay, same directions again. Find all rational zeros. Now, keep in mind, they just want rational ones. So if there's a root here that you can't write as a fraction, I don't want it. I only want the ones you can write as fractions. All right, so we can use the calculator to help us out, but we don't know what to even try in the table. So what's the first thing I have to do?
Factors of 6.
Yeah, I got to write those factors out. Got to generate my possibilities, and then I'll try them in the table. Okay, Pat, what are my factors of P?
6.
Carol, that one's Q.
Oh.
Plasma charge.
And help them out. What are your factors of p here? Yep,
Plus minus 1.
plus or minus 1. Okay, what about q? Yep,
Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6.
yeah. So even though we got kind of a lot for q, there's only 1 for p, so we're not going to have that many. It's 1 over every one of these. Okay, so we'll just write those out. Yep.
Okay, so like, this is what I was talking about, like with the repeated root, because there's plus minus 1 for q and then plus minus 1 for p, so it's like repeated.
Yeah, so let's say you took positive 1 and divided by positive 1. Okay? That's just positive 1. If you took positive 1 and divided by negative 1, that would just be negative 1. There's no other pairings you can really do to get anything different other than that. So whether you divide negative 1 in the top and then do positive 1 in the bottom, switching them, it's still negative 1. So it's not a new option. All right, so we got our list. Okay, now we're going to graph it. We're going to look for one of those 8 numbers. If we can find one, we use synthetic division. All right, so we got 6x cubed minus 5x squared plus 3x minus 1. Oops. And zoom 6. Okay, out of this list, which one looks maybe like a possible root? Yep. 1/2. Let's try it. 1/2 is a root. Yep. Great. So
What do I have to do to be able to put stuff into the table?
if you want to type in, go to second table setup, and then put the independent on ask, put the dependent on auto. Yep. Otherwise, it gives you a list and you can't type in. Yep. All right, so 0.5 is a root. We're going to divide through by it. When I do that, this cubic is going to turn into what? It's going to turn into a quadratic, and then I can maybe factor it again or use the quadratic formula. All right, so 6, -5, 3, -1. Okay. And since 1/2 is a root, I already know my remainder is going to be what? 0. So if I don't get remainder 0, we did something wrong. Okay, bring down my 6. Okay, half of 6 gives me 3. Okay, what's -5 plus 3? -2. Half of -2? -1. 3 plus -1 is 2. Half of 2? 1. Remainder 0. All right, so I've got x minus 1/2. That's a factor. And I already know the root. 1/2. Okay, what's my other factor that I get from the quotient?
Since s squared squared plus 2.
All right. What we could do to make that a little easier is factor a 2 out of each number, okay, just to make it a little smaller. So we get 3x squared minus x plus 1. That 2 doesn't change our answer at all. It just pull it out, makes everything smaller. I don't think we can factor that. 2 numbers that multiply to give me 1 and add to give me -1. Okay. So let's just set up the quadratic formula and see what happens. Okay. What's A? 3. And B?
-1
And C?
plus 1.
Okay, this number right here is a problem. Something is going to happen, and you'll see in a second. So we've got -b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, just focus on this part. What's going to happen there? It's going to be what? What's 4 times 3? 12 times 1? 12. Now what's going to happen on that part? It's going to be negative. Okay? It's negative 11. Can you take the square root of a negative?
That'd be imaginary.
That'd be imaginary. Okay? They didn't ask for imaginary answers in this problem. So this is the only answer. There are no other rational roots. Okay? Which we can also confirm by looking at the picture, which I don't think we've done. Oh yeah, we did actually. Okay? You can see it only crosses one time. This is the reason why. Okay? Yep. Okay, any question on that? So the last one, we got a quadratic. We could actually get a couple more answers out of it. This one, we got a quadratic. It came out imaginary. So we're not going to worry about it.
You got the 3x squared minus x plus 1. You divided the answer there, 6, negative 2, 2.
Yeah, I divided everything by 2. I factored out a 2. I didn't even have to do that. I could have let a be 6, b negative 2, and c 2. I would have gotten the same thing.
Okay.
Still would have gotten a negative number here. No.
Why isn't b negative 1? Yeah.
Oh, thank you. Negative 1. It's still going to mess us up. So now we have negative 1 take away 12. Is negative 1 minus 12 still negative? Yeah, thank you. Yes, that is important. But luckily it didn't affect our problem. So you still have a negative number. Is that what you were going to say too? Yeah. Okay. Any other questions? All right, so this will be our last one. Okay, same type of problem again. Find the roots. I'm just trying to make sure I give you plenty of practice. Directions are a little different though. Find the ones you can write as fractions and the ones you can't. Not imaginaries. But if you get an answer that's like square root of 5, that's okay. I'm asking you to write the irrational answers as well. Again, this is a cubic. That's usually the one I'm going to give you, something that's a degree 3. Because if you can find one root, you can turn that cubic into a quadratic. And then from there, we can solve it. And we just don't have a formula called the cubic equation that we use in this class. Okay, there is one. It's very complicated. It's not like the quadratic formula at all. It's like the quadratic formula times 100. It's very hard. So we're going to use our rational root theorem, hopefully find one root, then use synthetic division. Okay, what are my factors of p here?
Wait, so you just said there's a formula for this?
There is. There's a formula for cubics. I don't even know it. I think it's like pages long. It's not even probably worth using. Just like the quadratic one, you can look it up. Look up cubic formula, and you'll find it. It's pretty long. Okay, what are my factors of p? Yep.
Plus or minus 1, plus or minus 2.
Yep, plus or minus 1, plus or minus 2. Factors of q, plus or minus 1, plus or minus 3. Right, so Derek, what are my possible rational roots?
Plus or minus 1.
Yep.
Plus or minus 1 divided by 3.
Yep.
Plus or minus 2.
2.
And plus or minus 2/3.
Plus or minus 2/3. Okay, we're going to graph it. That'll save us a little time from trying all 8 of these numbers. Look at one that looks close, then try it, then use synthetic division. Because this is a very step-by-step process. You really do the same thing each time. All right, so we get 3x cubed minus 8x squared. Plus x plus 2. All right, so out of those 4 numbers, which one looks like it might be a root? 2? Let's see. We could try 2, but I think it's between 2 and 3. I'd say 2/3 looks like a root. It is. So we're going to divide through by 2/3. We're going to turn that cubic into a quadratic. Okay, what are my coefficients going to be?
3, negative 0, I mean 1. Was it?
3, -8, 1, 2. Okay, bring down to 3. Okay, and this won't be too bad to do in our head. What's 2 divided by 3 times 3?
2.
Just 2. -8 plus 2.
-6.
And now the way you can do this in your head, what's 2 times -6?
-12.
-12. Now divide by 3.
-4.
-4. Okay. Add these up. And we just kind of did this earlier. What's 2 divided by 3 times -3?
Negative
-2, which it should be. Remainder 0.
How do you get to the little table on the graph that you can function?
Table, second table. All right, so I know x minus 2/3 is a factor. So 2/3 is a root. Okay, so I'm starting a box for my answers. Okay, my quotient. How about Matt? What's my quotient here?
3x squared minus 6x minus 3.
Perfect. 3x squared minus 6x minus 3. And this might be factorial, maybe not. But what could I do to make all these numbers a little smaller? I could take out a 3. If you don't mind working with bigger numbers, don't do that. Leave it the way it is. But that gives me 3x squared minus 2x minus 1. 2 numbers that, let's see, is this factorable? I don't think so because of the signs.
I thought there was +1.
Yeah, if you had a plus in there or something, you could probably do it. So it looks like it wants to be factorable, but it's not. Okay, so let's try the quadratic formula. What's A?
1.
B?
Negative 2.
C?
Negative.
All right, this negative here is a good thing because that's going to cancel the negative under the square root. So we're not going to get an imaginary answer. All right, so we got negative b plus or minus the square root of b squared minus 4 times a times c, okay, all over 2a, minus a minus. That becomes a plus. 4 times 1 is how much? Plus 4 more? 8. And how does the square root of 8 reduce? Yep, you can write it as square root 4, square root 2. 4 times 2 is 8. And what's the square root of 4? 2. Square root of 2 over 2. And you can cancel a 2 from everything that's not under a root. 1, 1, 1. Okay, so our final answer is 1 plus or minus square root 2. So I'll write those up here. So my 3 answers are 2/3, 1 plus square root 2, 1 minus square root 2. Is that one rational or irrational? Rational. Rational or irrational?
Irrational.
That's irrational because it has a square root in it. Good. All right, so I know we did a little bit of extra practice. We did a lot of those finding roots, but I think it's just good to practice the same thing a little bit. Okay, that's the homework for tonight. Page 183. 1, 2, 5, 6, 9, 10, 13, 14, 17, 18, and 27. All right. We'll take a look at that tomorrow, and then tomorrow we will finish up everything for the week.